Hello everyone. In this video, we will discuss in detail about our project's hardware and its connections, software codes and working of our project. First of all, we will be initiating with explanation of hardware connection through the circuit diagram in detail. So, this is the circuit diagram prepared by our project team. Now, first of all, we would like you to have a look on the L293D motor driver IC inserted on the breadboard. L293D motor driver and its pin configuration is very extensively explained in our project report, so we will not do that here. Now in the connections, first we will explain at the power connection between the L293D motor driver and our Arduino Mega 2560 board. The first connection we made is at pin number 1 at position D3 to the pin number 16 at position G3, which is VCC that give power to the motor driver. After this, we connected pin 9 at position H10 to the pin number 16 at position H3, which will help us to make a common power port from the breadboard. The purpose of doing this was to have a single power supply, which is not a problem. Lastly, we joined pin 16 at position I3, which is VCC, to the 5-volt port of our Arduino board, and this concludes the power circuitry. Note that for easier understanding, all our power network are red-wired. Now coming to the ground circuitry, we connected pin number 4, which is the ground pin at position D6, to pin number 13 at position G6, which also serves as ground. Similarly, just below to pin number 4, we have pin number 5 at position D7 connected to pin number 12 at position G7 of our motor driver. Then in the later network, connections from G6 and G7 are made common via H6 and H7 through the ground at pin number 12 at position I3, which is then connected to our Arduino's ground port. Here also, the only purpose of doing these interconnections is to make a common ground, which is at position I3. Note that for easier understanding, all our ground circuit is black wired. And finally, this concludes our ground circuitry. Now, we will see the input connection of L293D motor driver to Arduino board. First we will show the input connections for left motor. Here, pin number 2 at position A4 is the input pin and is connected to the digital pin number 10 of Arduino board. Also pin number 7 at position A9 is the input pin for left motor connected to digital pin number 37 of Arduino board, which are both orange colored wires. Now for the right motor. Pin number 10 at position J9 work as input and it is connected to digital pin number 36 of our Arduino board. In the similar fashion, pin number 15 at position J4 acts as an input for right motor and is connected to digital pin number 11 of our Arduino board, which are both green colored wires. An important thing to note here is that our pin number 2 and 15 of our IC are connected to digital pins number 10 and 11 respectively, and these are the PWM pins of Arduino board as well. These PWM pins allows to change the duty cycle of the signal to the motor and help to control the speed of motors, which we will see in the later sections of the video. The principles and operations of PWM signals have been extensively explained in our project report. Now, we will see the motor's connection that is done to the L293D motor driver. As we already discussed through input connection that we are controlling two motors which are left and right motors, there will be separate output pins for them. If you look at the breadboard carefully, pin number 3 at position A5, blue colored wire, is connected to positive terminal of our left DC motor. Followed by this pin number 6 at position A8, violet colored wire, is the other output for left motor and is connected to the negative terminal of left motor. Now for our right motor, pin number 11 of our motor driver at position J8, orange colored wire, acts as the output and is connected to the positive terminal of right motor. Similarly, pin number 14, yellow colored wire, at position J5 acts as another input and connected to negative terminal of our right motor. And this sums up our motor's connection. We would also like to mention here the use of external supply. As we used two DC motors of 12 volts ratings, so it's nearly impossible to control both of our motors with 5 volts supply from the Arduino board. As a result of this, motors will not be able to draw even a very small amount of load. To solve this problem, we just added an external supply through adapter of 5 volts. As far as its connection to our project is concerned, we connected the positive end of adapter to pin number 8 of our motor driver, which is VCC2, in the negative terminal to Arduino's ground port, both brown colored wires. Ignore the polarity taken over here. Ratings of the adapter are also mentioned for reference. And this completes the hardware circuitry and connections. Now, we will discuss in detail about the programming we did to our Arduino 2560 megaboard for controlling direction and speed of DC motors. So, our Arduino 2560 megaboard is programmed through a software which is supported by the integrated development environment of the Arduino community. It is an open-source programming software, namely Arduino.cc, and anyone can simulate the Arduino board through the codes using this software. Now we will discuss about our project's programming.
The code structure is somewhat similar to C programming language. We first use the function integer, which helps to define two pins that can be digital, analog, PWM, transmission, etc. If you rewind the video to the input connections, you will see only pin number 11, 36, 37, 10 are connected to the motor driver, where we defined pin number 11 and pin 36 as forward and reverse pin of right motor respectively, and pin number 37 and 10 as forward and reverse pin of left motor respectively, and will work like input, so whichever command we give through these input pins, output are concluded, and here, our output is our motors. Also, the forward pin can be called clockwise pin, and reverse pin can be called anti-clockwise pin. After defining pins, we use the function void setup, which help us to start the code and define input pins to perform specific tasks throughout the code. After using this function, we began the code with curly brackets and use another function, pin mode, that helps the compiler of software to understand the works of these pins. In our project, as we wanted to control speed and direction of motor through these pins, so we set all of them as output. Then this void setup is closed through our curly bracket. After accomplishing these steps, main parts of program comes into picture. We use the function void loop and it repeats the code after it ends. We use the function digitalWrite, which acts as a boss who will extract work from his employees. So in the first set of code we kept right motor pin 11 high and that too in forward here, clockwise direction, and all other 3 pins low. Here high pins act a binary digit 1, which means on state, and low pin act as binary digit 0, which means off state. So in the first case motor goes clockwise. Also, if you saw in input connections, the pin number 11 of Arduino was a PWM pin, so we decreased its duty cycle to 178 by using the function analog write, which automatically reduced the speed of the motor. After all this, we used a function named delay, which allows to sets the time that the previous code will run, here set for 6000 milliseconds. In the similar fashion, in the next code we coded the left motor forward pin, here clockwise as high and all other as low, so left motor will go in clockwise direction for 6000 milliseconds. Then we coded right motor reverse pin 36, here anti-clockwise as high and all other pins as low, so right motor goes in anti-clockwise direction for 6000 milliseconds. And then left motor reverse pin number 10 as high and all other pins as low, so left motor goes in anti-clockwise direction for 6000 milliseconds, and here also using analog write function we reduce the duty cycle to 190 to reduce speed of left motor in anti-clockwise direction. Lastly, for running both motors together we first set the left and right motors forward pins high and other 2 low, so both motors rotate in clockwise direction, and then left and right motors reverse pin high, so both motors rotate in anti-clockwise direction for a time duration of 7000 milliseconds. After accomplishing all these code sets, our program will run from first line as we used void loop function. And this conclude the detailed discussion of programming.